Hi, good morning, everybody. We're going to be taking a look again at just permutations today. The last time that we did an assignment together, we talked about finding the value for n, which is how many total items you have to choose from. And then we talked about finding the value for r, which is of that total, how many or what number are you selecting from that group. And remember that permutations are the ones where that when you create that group, it makes a difference to the problem the order in which that group appears. The formula for finding permutations is going to be n factorial, n exclamation point over n minus r factorial. So if you weren't with me last term, you might need to know that factorials are explanation points. And they do something pretty easy to understand, but you don't really see it until you put a number in. So in all of these problems here, the first number that we see in this little rig setup here is going to be our n number. And the second number that we see is going to be our r number. So it's just that easy. So anytime I see an n in this equation, I'll put a 4. And anytime I see an r, I'll put a 2. So my equation is going to turn out to be 4 factorial over parentheses 4 minus 2 factorial. Perfect, okay. Then we have a little bit, we can simplify 4 minus 2 we know is 2, so that's going to be 4 factorial over 4 minus 2 on the bottom is 2, so 2 factorial. So now a little bit of catch up. If you don't know what a factorial is, 4 factorial means you're going to do 4 times 3 times 2 times 1. You always stop. You go down until you stop till you get to 1. So 4 times 3 times 2 times 1 on the top. On the bottom, can you guess what 2 factorial is? It's going to be 2 times 1. And when I do that 2 times 1, check this out. I'm going to line it up so it matches the 2 times 1 on top, because something pretty special happens here. We actually get to lightsaber out the matching terms, and we're left with only a 4 times 3, which we know is 12. And that's our answer to our permutation. So it's a little strange, but it's probably because we don't really know what question did we just answer. You just said to do 4p2, but what does that really mean? What that means is you had 4 options. So like say you had 4 posters you wanted to hang up in your room. The 2 means of those 4, how many ways can you hang up 2 of those posters in your room? And so if you had 4 posters, you wanted to hang up 2 of them, we now know that there are 12 ways that you could hang up those 4 posters, or of those 4 posters, you could hang up 2 of them. So all of these problems are going to be just like this. Number 9 and 10 are a little bit different. If you look at those ones, if you think you know what to do, try it out. Otherwise, feel free to cross out these extra bits and just do the part where it says a number p number, a number p number. For 11 through 16, which is our next set, you are going to be counting how many ways can you rearrange these letters. And so what you're going to do is you're going to count how many letters there are. So in design, there's 1, 2, 3, 4, 5, 6 letters. And if you're going to be rearranging all of those letters, then you just do 6 arrangements or permutations. And I'm going to be arranging all 6 of those letters just like that. For problems like 13, do you see that you have repeating letters here? So you're still going to count how many letters you have. So cheese has 1, 2, 3, 4, 5, 6 letters. But now when you create arrangements of them, you want to count how many arrangements of unique letters are there. So how many unique letters are there would be your